classes and interfaces are key concepts in object-oriented programming, in addition to data hiding and polymorphism. Data hiding is when you define the data private and assign get and set methods to access this data. It is also known as data encapsulation. So the class becomes a capsule to protect accessing data from outside the class. Polymorphism, on the other hand, it means multiple shapes. An example of polymorphism is overloading of a method, so that the same method has different signatures, so we say it has different shapes. First, we will explain the meaning of inheritance, and then we will explain the meaning of abstract classes and interfaces and how to implement them in Java. So what is inheritance? Inheritance allows new classes to extend an existing class, and then this new class will inherit the members of the class it extends. So in other words, inheritance allows you to define a very general class and then later define more specialized classes that add some new details to the existing general class definition. Doing this, it will save work because the more specialized the class inherits all the properties of the general class, and you as the programmer need only to program the new features. When you apply inheritance in Java, it allows you to create what is called a class hierarchy. Now, for example, suppose we would like to create a class for a person. So we have to put the information for a person, for example, name, CPR, address, telephone number. So this will be considered as a general information. Now, suppose we would like to create another class for a student. And you know that a student will have the same information for a person. So the student has a name, has a CPR, has telephone numbers. In addition to these information, the student has specialized data, for example, student ID, GPA, that not any person have this information. In this case, you don't need to create a new class for a student. You can extend the person class, and this information for person will be included in a student when you extend this class and add additional data, for example, the student ID and GPA. So this feature will allow you to create a class hierarchy. You start with a basic class, which is person, and then you extend this class to derive the classes. So the person class will be considered as the basic class, which is called superclass in Java, and the student and employee will be the derived classes of person, which we will call them subclasses in Java. So the student class will inherit all public data and methods from person, and we say that the student extends person. Note that an object of a student has all of the methods of person in addition to all of the methods of a student, so that a student is a person. This relationship is called an is-a relationship. You should use inheritance only if an is-a relationship exists between a class and a proposed derived class. So for example, why we consider student as a subclass of person? Because we say that a student is a person. We say that employee is a person. We say that faculty is an employee as well as is a person. Our next question is how to implement inheritance in Java. We will base our discussion in this lecture on a basic class that is called graded activity. We will consider this class as the superclass that has all the shared data and methods for any exam. This is the UML implementation for the graded activity class. It has one private data member as a score. It has one data member score as double, and it has three public methods. The first two methods for accessing score, one for set and one for get. The last one is for assigning a grade letter according to the score. Let us see the implementation for the graded activity. Now this is the implementation for the graded activity class. As you can see, it has one private double data member for score. Next, it has the method for setting score and a method for getting score. The third method is for assigning a grade letter according to the score, either A, B, C, D, or F. After defining the graded activity as the superclass, we would like to define a final exam as a subclass of the graded activity. This class inherits data and methods from the superclass without any of them being rewritten using inheritance. This is the UML implementation for the final exam. As you can see, it has 3 private data members, one for number of questions as integer, one for the points for each question as double, and the other, or the last one, is the number of missed questions as integer. In addition to the private data member, it has the constructor for initializing number of questions and number of missed questions. It has a getter for points for each question and a getter for number of missed questions. Now let us see the implementation for the final exam class. The final exam class definition is on the right hand side. And now we will explain on how to tell the Java compiler that this class extends a basic class. We write public class final exam, followed by the keyword extends, followed by the class name for the basic class. So here we are telling the Java compiler that the final exam class is an extended class from a graded activity. Let us have a look into the definition for the final exam. It has 3 private data members, as we discussed before, number of questions, points for each question, and number of missed questions. It has the constructor that will copy the parameters number of questions and number of missed questions into the private data members, and it will calculate the score. So how it calculates the score? First, it will divide 100 over questions. This will give us the points for each question, and then we subtract from 100 the points that are missed for each question. Now this score is saved into a local variable inside the constructor called a numeric score. Now we want to save this score into the inherited score that is in the graded activity class. Notice that when we say extends, that means the data and methods are available in our extended class. But since the data in the inherited class is a private, so we cannot access it directly. That means we cannot say here score equal a numeric score. But notice that we have a method that is public for setting a score. So therefore we can call this inherited method by saying set score, and we supply numeric score as parameter. It will copy it into score. So the data score is not inherited, but it was available. But the method set score, because it was public, it was inherited and used inside final exam class. In UML diagram, an up arrow is used to represent inheritance. In this diagram, the final exam class is an extended class from the graded activity, so it inherits all the data from graded activity. So new data and methods may be added to the subclass. In our example, number of questions, points for each question, and number of missed questions. So the Java keyword extends is used on the class header to define the subclass. And this is how it is done, by writing public a class. This is now the subclass final exam. The keyword extends, graded activity. Now this is the superclass. Now let us have a demo program to demonstrate on how to create an object from the extended class final exam. In the main method, we ask the user to give us number of questions, and we ask the user to give us number of missed questions. Then we create an object from the final exam class, and this is the UML diagram for the final exam. As you can see, it is extended from the graded activity class. After creating the object, we are calling the methods for final exam. First, we are calling the public method getPoints that will display the number of points for each question. And then we will call the public method that is inherited from a graded activity called getScore. So getScore is not defined in final exam, but it is inherited from a graded activity, and this will print the score of the exam. Also, we are calling the getGrade method that is also inherited from a graded activity, and this will print the letter grade according to the score. We are in JGrasp. We would like to see the implementation for the three classes: the graded activity, which is the super class, final exam, which is the subclass, and final exam demo, the program for demonstrating how to create an object from an extended class. So let us go over the graded activity. This is the graded activity. It has only one data member, that is a private score, and it has setScore and getScore and getGrade for assigning a grade according to the score. Now let's go to the final exam. As you can see, the final exam, it has its own data. All of them are private. It has a constructor, and it has getting method for get points each, and getter method for get number of missed questions. And we have finally the final exam demo for demonstrating on how to create a final exam, which is an extended or a super class from graded activity. Now let us first compile the graded activity. We don't have errors. Let's go to final exam. And now finally run the program for the demo. Okay. So we are now in demo, so run the program. So now it's asking how many questions. There are 10 questions. How many the student did miss? 3 questions. So the score is 70. Each question counts 10 points and the grade is C. As we said before, that if we have a private data member in a super class, it is not inherited. However, it is in the memory. So we cannot access it directly in a subclass. So now in here in final exam, if you go to the constructor below here, as you can see, we are using a public method for setting the score. However, if we define it as public, so let us change it now to public. Compile it. And now when we go to final exam, there is no need for setScore because it is inherited and can be accessed directly in the subclass. So simply we can say here score equal numeric score because we can access it directly. So now let us compile. So as you can see, the compiler did not complain that there is a syntax error. However, if I return back to graded activity and return the data member to private again, compile it. Now let's go to final exam and try to compile it. As you can see, it says that there is a syntax error because the score has a private access in a graded activity. So to access it, we have to use the set method for score because the private data is not inherited and cannot be accessed directly. So now let us compile it. So as you can see, there is no error. The conclusion is that members of the superclass that are marked public are inherited by the subclass and can be accessed directly from the subclass in any method. However, members of the superclass that are marked private, they are not inherited by the subclass, but they exist in the memory when the object of the subclass is created. So how they are accessed? They only be accessed from the subclass by public methods of the superclass, for example, setters and getters.